So this morning we're talking about strings, and let's just recall what strings are. A string is just a sequence of characters enclosed in either quotes, which could be either single quotes or double quotes. And if you've got one kind of quote inside a string, then you need to use the opposite kind of quotes from what you've used to identify the string itself. Okay, so on we go with strings. So the first thing I want you to do is to create a string, my underscore name, and it's contain your name, your first name and last name separated by a single blank space. Then put the second character of your name in the variable second and print second. Okay, pause the video, do this, and then come back and restart the video. Okay, you're back. My underscore name is Harold Nelson. And the second, of course, is my underscore name bracket 1 because Python, as I've said probably about 1,000 times by now, starts indexing from 0. So the second is lowercase a. Compute and print the length of the string my underscore name. Just pause for a couple seconds and do this, then come back and we'll talk. So to compute, in a sense, the length of the string, you use the function len. And my name is 13 characters long. So I want you to extract the last character of my name and print it, but use a positive index. Don't use the -1 trick. Okay? So pause the video, do this, count the number of characters in your name. Well, you know the number of characters in your name, and then decide how you're going to get at the last character. Okay, you're back. So my name is 13 characters long, so the last character in it has the index 12, one less than the length 13. And the last character in my name is the lowercase n. So I want you to use a while loop to print each character of my underscore name. Okay, this will take a few minutes, so please pause and do this. Okay, you're back. Let's take a look. The length is the len of my underscore name, and I'll start with a position of 0. And then while the position is less than length, print my underscore name of position, and then add 1 to position. And this worked correctly. I got Harold Nelson. In terms of the sort of variations on a theme that we talked about when we introduced while loops, I started the thing that I'm the loop variable at where I want to start, that is at position 0, and then I used the less than while position is less than length, and then I incremented position at the bottom of the loop. Okay. Then I want you to use a for loop and the in operator to repeat the exercise above. Okay, this will just take you a couple seconds. But anyway, pause the video while you do it. You're back. This is real simple. For letter in my underscore name, print letter, and it works. The point is that the definite loop is much, much easier, and you don't need to think about indexing at all. So I want you to create and print a string called straddle, consisting of the last character of your first name, the blank space, and the first character of your last name. And this is an exercise in slicing. So stop the video and do this, then come back and we'll talk some more. You're back. My name 5:8. So the HAROLD, so the D is the sixth character in the string, and I get to it with the index 5. Then there's characters 6 and 7, so I stop at 8 because the last thing I want is the character with index 7. Okay? Of course, for you it'll probably be somewhat different. So I want you to manually locate the index of the blank space and call it blank underscore pause, and use this variable to get strings, first underscore name and last underscore name, using slice specifications, only using the one number, and then print the value of blank underscore pause, first underscore name, and last underscore name. Okay, this will probably take you 4 or 5 minutes, so please stop the video and do this, then come back and look at the way I've done it. Okay, on we go. Let's look. The blank underscore pause is 6 because it's the 7th character in the string. So the first underscore name is my underscore name starting at 0 because there's nothing before the colon, and ending 1 before blank underscore pause. So the stop value is blank underscore pause, so we don't include the blank underscore pause. The last name begins at blank underscore pause plus 1, that is 1 after the blank position, and goes all the way to the end, so we have a colon with nothing following it. And then I print blank underscore pause, I print first underscore name, and I print last underscore name. So the blank pause was 6, and there's my first name, and there's my last name. So I want you to use find to locate the position of the blank space in my under name, and call that blank underscore pause underscore 2, and then check to see if you get the same thing for blank underscore pause underscore 2 as blank underscore pause. And obviously you should if the find works correctly. So stop the video, just do this. It's a pretty quick little exercise. Okay, you're back. Off we go. To find the blank underscore position, use the find method, and it finds the first occurrence of blank space. And then I test, is this the same thing as I got with blank underscore pause? And yes, it is true. So now we're going to do a little bit of exercises with string functions. And I want you to create lower underscore name, your name in lowercase letters. Create cap underscore name, your name capitalized, starting from name underscore lower. and create both caps. Both your first and last names are capitalized. Upper underscore name, your name in uppercase, starting from lower underscore name. And then I want you to create devoweled, which is your name with every vowel replaced with X. Okay? So take a few minutes and do all of these things, and then we'll come back and talk about it. Okay, you're back. So to get lower underscore name, you just use the method lower and apply it to my underscore name. And then I print lower underscore name, and I get this. Cap underscore name is lower underscore name dot capitalized, and print cap underscore name, and I get Harold Nelson. Note that I capitalize the first name, but it doesn't capitalize the last name. To actually get both capital letters, I get both underscore caps as lower underscore name dot title, and then print both caps. And that got me this. Both the first name and last name have been capitalized. Then upper underscore name is lower underscore name dot upper, and that gets you Harold Nelson. And then the last thing is a sequence of replacements. First, I create the string devoweled, which is my underscore name dot replace A with X, and so on all the way through U with X, and I get this thing, which is replaced every vowel with an X. Okay? Create a function check, which returns true if a name ends with sen or son, and returns false otherwise. Test your function with the names Johnson, Smith, and Anderson. So let's take a few minutes and do that. Okay, let's take a look. So here I've created the function check with the keyword def, and it has a parameter name, and it returns a Boolean value, which is that either the name ends with son or the name ends with sen. And then if I check Johnson, I get true. If I check Smith, I get false. If I check Anderson, I get true. Okay. So let's talk about immutability. A string is immutable. Once a string is created, its value can't be changed. So if you try the following code and observe what happens, it attempts to capitalize a string. It attempts to replace the first character with the letter capital A. And what happens? Well, it fails. And you get the message type error, str object does not support item assignment because a string is immutable. But here I said s equal quote ABC, s equal s dot capitalize, print s, and I succeeded. At this point, the string s was ABC. Now the string s is capital ABC. It looks like I managed to cheat and violate immutability. And there's a link here that you might want to follow up if you want to read a little bit more on this topic. And the bottom line, here's the fact, the way to think properly about this. There's a name, there's an object, and there's a value. Those are three distinct things in Python. You can't change a string object, but you can use a name to point to a different object. So I want to explain the following. First, I created a string S, which is ABC. Then I created a string T. Well, I used a name T as an alias for S. And it is just an alias because if I print the ID of S and the ID of T, I get exactly the same thing. Okay? In other words, these are the objects, these are the locations of the objects to which the names S and T both point. Now I say S is S dot capitalized, and what happened? And I print S and I get ABC. But if I print the ID of S, I see that it is different from the common ID that S and T had before. And if I print T, which is an alias for the original S, what I see is ABC. So the point is that at this point, the name S referred to one object. At this point, the name S refers to a different object. So I am reusing the name. I'm not actually changing the string S, although it appears like it. It appears like that's what's happening, but it's not. Okay, we can use our accumulation pattern to build a string by starting with an empty string and then adding to it by concatenation. I want you to use this fact to write a program to start with the string, use this fact, and build a string consisting of all the vowels in the original string. And to do this, you'll need to start by creating a string consisting of all the vowels, both uppercase and lowercase. And remember that the operator in can test for the presence of a character in a string. Okay? So stop the video. Please do this. This may take you as much as 10 minutes. I don't know. But anyway, stop and do it right now. Okay? Then come back and see the way I've done it. Okay, you're back. So the first thing I do is to create the string vowels, which is lowercase vowels and uppercase vowels. And then I've got the string S, which is use this fact. Then I'm doing an accumulation, so I start with nothing. And nothing in the case of a string means a string of 0 length with no characters in it. Then I look at every I in the string S. And if that value of I is in vowels, which is this string, then I concatenate the current value of res with the current value of I. And then I print res when I'm all done, and I get UEIA. Okay? So stop and look at this and think about the way this works. So I want you to repeat the previous exercise with a little twist. In addition to accepting only vowels, require that the index of the character be even. That is 0, 2, 4, 6, etc. Okay, stop the video, do the exercise. Okay, you're back. I hope you succeeded. So we start off basically the same way we did at the beginning. The first three lines are exactly the same. But then what we're doing is we're iterating over the enumerate of S, not just S itself. So when I enumerate, I've got access to both the index of the character and the character itself. So if the index is even, that is, if the index divided by 2 has a remainder of 0, and the character is in vowels, then I increment res with the character. And it turns out to be exactly the same as I had before, because all of the indexes of vowels were even. Okay, so stop and look at that and make sure you understand how it works. Again, the trick is to iterate over the enumerate of S, not just S itself. So the last exercise is to write a little program that prompts the user for the name of a file and then outputs that file's type, which could be docs, HTML, PNG, JPG, etc. Case insensitively. Assume the name includes only one dot. So stop the video, do the exercise, then come back and look at what I've done. Okay, you're back. Let's look at what I've done. So fn is a string, input the name of the file. And I put a blank space after the question. Then I locate the dot. Dot underscore loc is fn.find of dot. And then the file type is the string that begins at dot underscore loc plus 1 and goes all the way to the end. Then I print the F type. And here I've tested it. The name of file, x.jpg, and the type of that file is JPG. Okay, so that is the end of the lecture on strings.